All right, guys, so we are recording. Let's share the screen. Okay, great. So let's go to the bright space. Okay, so ITS 530. Okay. Let's go to content. All right, so we have covered, so I'm just going to do a quick recap. We have covered Hugging Face, Transformers module, all those birds and everything, GPTs. Remember, we were just doing inference, right? So that means we were grabbing a model and just using it, right? Then we went over the GPTs theory and the birds theory. And we talked about the word embeddings. Okay, so we've covered that. You guys did the pre-training of a GPT from scratch, and we've had the lectures basically on the algorithms of transformers. So you have the link to chapter 10 that I gave you guys. Read through that one. Okay, and then what we have left is this is the homework, and then there's the what you had your next assignment, if you will. This is a much more somewhat difficult assignment. It is the RLHF assignment, but here you've seen that, you know, you could do this from scratch, right, with the GPT code, but it probably, you know, you run into problems, right? So how do you get a pre-trained model, etc.? So here we're going to start leveraging Hugging Face, basically the hub. So that means, you know, we want to start with a GPT-2 or above, you know, up to Llama. All right, so the next set of exercises that I will do are basically fine tuning, right? So now I'm going to fine tune some models. And then basically finish. I've already done a demo of RLHF, but that's kind of the sequence. So we're going to do some fine tuning and discussion of how that works in Hugging Face, and in particular, how they have this very convenient function called trainer, basically. And that's what we can use. And then your mini project RLHF, I haven't really set a date for that. Maybe the middle of the semester will be, and you know, I'm giving you more time, but you can start working on it right now. Okay, today I have one last lecture of transformers to kind of wrap everything up. And this is, I think, although it does involve some linear algebra operations, I think it should be like very to the point, and I think it'll make things very clear, right? So I did prepare this one. So I do have certain things that I want to show you guys in case you want to start. Apparently Scholar is down, right? So for some of you, so I'll probably end up demoing this next week. But because from now on, everything needs a GPU, that's for sure. If we're going to be fine tuning. But I did run some exercises, and I added them there in the repo. So if we go to GitHub and you go to transfer learning, go to Hugging Face Transformers. And in here, I have this 2024. So basically this year. So these are all the Jupiters that we've done, right? So Hello GPT, in class, intro, and the sentence similarity that we did last week, right? Where we talked about embeddings. And then this is basically where we're moving to now, all right? So if I write GPU required, it won't, if you don't use a GPU, this is not gonna, it's gonna take forever. I have been doing these with the Scholar GPU just to kind of follow along with you guys. I will start with this one, fine-tune example. This is an example of fine-tuning a GPT. So what is fine-tuning? You guys should know this by now, right? What is fine-tuning? Yeah, please.
It's taking a pre-trained model that's already been trained with a bunch of data and giving it specific data to get it to work specifically with that.
Be better, right? Do you need to give it a lot of data when you fine-tune?
I mean,
in relation to when you pre-train? No, right? So in fine-tuning, 100,000 examples of text might be good enough. Do you guys see that? That's the contrast, but we still need a GPU because it's still a big model, etc. Right? You guys see that? So we freeze some of the weights. I think I did an example of that at some point where I showed you how we would freeze the weights in PyTorch. That's if we were doing all of it from scratch, but because we're going to be using Hugging Face, a lot of that is done behind the scenes, right? So it's really about learning how to do that. So this script will be about fine-tuning a GPT, all right, with Hugging Face. This one will be about fine-tuning a BERT. And then basically here, I have this other one, text classification glue, which will be also fine-tuning, but for a specific task. Now to classify, for instance, or something like that. Does that make sense? So this is the next step, but this does not get you to RLHF yet. This is like in that direction, but remember that RLHF has an additional component. What is that additional component? The reward. The reward function. Remember that in the example, we needed a sentiment BERT to provide the reward. That's actually, as I was saying to Jacob, that's probably for your mini project of RLHF, the most challenging part. What are you going to do there? Do you see that? So, you know, getting data and getting it in the format, yeah, it'll be difficult, but, you know, it's just work, most likely. But what is going to be the appropriate reward function for your task? Because if you were doing sentiment, then yeah, you know, you use sentiment BERT, but you're going to be doing different things. Do you guys understand? So RLHF is, you have a model, it can already do some, you know, it's pre-trained, then you fine tune it to write good movie reviews. But remember, in the example, RLHF was about making the movie reviews more positive, right? So you were then, the GPT would generate text, and the reward function would say, no, this is still too negative. So then it would update the weights. And then, okay, this one is more positive. And it, you know, and it updates the weights accordingly. You guys have to do something like that. You know, I gave the example of a GPT that talks about the election this year, the politics, right? And right, so it's good at answering, you know, about politics, but then you want to make it more Republican or more Democrat, right? So what does that mean? You need to have a Republican BERT or a Democrat BERT. Do you see the example? So obviously that's just something that I'm saying, but you need to look for something like that. You know, how do you do that? Got it? So I leave you to go through the Hugging Face hub, look for this. Maybe if it's available, just plug it in instead of your sentiment BERT. Otherwise, maybe you can train your own BERT to do that, right? There are ways, but then there's an additional training. Does that make sense, guys? That's the RLHF. Okay, so we will come back to that idea, but I discuss it with you guys right now. You already have the code example because I provided. And then in the next set of examples that you can expect, I will be using these three. I probably won't get to them today because I do have the last lecture on transformers today, and specifically attention. I want some additional things to be covered. But you can start playing with these. So I'm going to show you just a couple of things that are important. So this needs 3.8 to run, Python 3.8, which you can go to the Scholar, for instance, and select the 3.8 Python environment. You know, it's the V100, as you can see. And then I ran the code, so it runs fine. I think it's like 30 minutes. One thing I want to show is just one technical thing. All right, here. So you're going to be using trainer, as you can see over here, right? Trainer is the function that Hugging Face has created to make your life very easy. You just give it the data sets, you give it some parameters, everything works, okay? This trainer is also in the RLHF code, right? But it creates these checkpoints. Trainer is going to create these checkpoints, and it might really quickly fill up your quota in, which is what I was talking about the other day in Scholar. So all you have to do is, you can see how there's this path, Scratch, Scholar, and then your username. And if you select that as the place where the checkpoints are written, then you're using the Scratch 1 terabyte. So that should be enough for you guys to to train your models. Does that make sense? Yeah, so play with this. As I said, I will, this is where we're gonna pick up as we start going over more Hugging Face examples. So at least these three and then the RLHF, okay? Any questions on that? Yeah, so definitely start playing with this and please start working on your mini project and hopefully you understand the challenges, okay? All right, so the last thing I wanna do of the Transformers lecture, if you remember, I provided this, yeah. So here's the whole code, or sorry, the whole description of the material. Certainly read through it. I did add something, a couple of things that I'm going to talk about today. So this is basically, I added this image. This is the example of the attention, right, that I was talking about. Remember? So attention mechanism is really what I'm going to focus on today, just that, and the operations that make this happen. If you notice there, I have added the robbers broke into the bank and stole money. The robbers broke into the bank and stole money. Remember, I'm not using subwords. I'm actually just using words to keep it simple and intuitive. This is also masked. So that means the mask that you put in, right, is also included in this. But remember that what it needs to do is it needs to learn the weights. Now the mask is included here, remember, so that basically if you look at the robbers broke into the, and then it can't see that the next word is bank. You see how it's zeroed out? That's the basic idea of masking, is that the text is there, but you mask it. You can't, you make it a 0, so therefore it's like it's equivalent to it not seeing it, so that it has to predict it as an output, and that's the objective. So basically, you can see the robbers, but you don't know what the next word is because it's zeroed out. Do you see that, guys? And the robbers broke into the bank is zeroed out, so it doesn't see it. That's the fine trick that they created in order for the model to never look ahead to the next word. But it does have to predict it as an output of the GPT. Any questions on that idea, guys? All right, great. So hopefully that makes sense. So I wanted to create this graph. If you remember, I haven't been able to digitize it yet, but this gives you an idea of attention. This is what is 40 by 40, remember? So what I want to do today is I want to go over the mechanics and just like very simply show you how this works. So I created, we are going to be focusing on head basically. So head, oh, there's another head above, sorry. So the focus of today's discussion is going to be the class called head. It's really where everything is happening. It's really the thing that confuses everyone. And really, if you understand this, the whole transformer should make sense, okay? So if you remember, I talked about this initially already. So, but today I'm going to just like break this down into pure, matrix multiplications and show you everything. So you can see here, if you remember, the X comes in, so you create these K and Q, you perform this strange looking multiplication, right? And I told you somehow that when you do that, it looks like that, right? And then the model learns the weights and then we translate it back, right? So this is what I'm going to discuss today. I provided a new Jupyter and I've linked it here. So you can see the linear algebra operations that make attention work, okay? So I have further broken down all the previous linear algebra operations using random data into this linked notebook. And I highly recommend that you guys go through it to try to understand it, okay? So it's basically this Jupyter. So this is what I'm going to do in today, all right? So we're going to do this in Anaconda. And just initially, I'm going to give you some notes on the whiteboard, okay? Just to kind of give you a little bit of background. And then we're going to do that. And hopefully that will make everything click. All right. And then after that, we'll be done with the theory and just get back to fine tuning and the RLHF. Got it? Any questions? All right, great. So let me switch over then to the whiteboard. this. All right, here we are. All right, let me grab my pen. Let me. May need to restart this computer sometimes. All right, so I'm going to have to restart this. Sorry about that.